That's what it's going to be about. I worked with SQL servers for many years, primarily doing ETL and relational data warehousing. I'm currently employed at the UN as a data warehouse architect at UNOPS. And yeah, if you have questions afterwards or things that were unclear or whatever, please feel free to contact me. That is my contact information on the screen here. So, what will this talk bring you, and what is this all about? Well, it's a talk for developers primarily. Not that I'm hoping to scare anybody away, but if you're a developer, this is for you. For everybody else, it's merely a nice to know. It's an introduction to in-memory tables and natively compiled stored procedures. It's also a demo about how we went about converting our application to utilize the power of being memory-based and memory-optimized. So what you're going to see here is code that we created with a real purpose in mind. It was, though, still a kind of playing around, trying to see what can we do with this new technology and what can it bring us. So I left the company that built this application, and I'm not sure if it ever went into production. So I can't say that this is a real production scenario, but at least it was built with the purpose in mind of taking it to production at some point in time. I will give you the tips and tricks that we learned to overcome the shortcomings of the product. Those shortcomings are mainly in 2014, so we will at the end look a bit ahead going forward, and well, that's not that much ahead because SQL Server 2016 is expected to go in real launch on the 1st of June, so I guess we're 2 weeks away from that, and in 2016 a lot of these shortcomings has been resolved by Microsoft. It's not a deep dive into in-memory tables. We're not going to look into DLLs or any other kinds of stuff like that. It's more like what can we do with this product, what can we do with this technology, how do we use it, and what can we use it for. So, in-memory tables, also known as codename Hackathon, that was how it all started, and now it's known by its marketing name, in-memory tables. So, in-memory tables is built into SQL Server, and there's no feature. It's nothing that you can tick on and off under installation. It's just there. It's built into the SQL Server.exe, and you can't even disable it. If you're on a SQL Server version that has memory tables, which means Enterprise or Developer Edition, starting from SQL Server 2014, then you will have memory tables as part of the product. So if we look at the diagram here and you pay attention to the arrows, then we can try and see what it is and how we are able to walk our way around this, the memory optimized tables and the procedures. So in this here, we have it split down by the middle. We have everything that's memory optimized to the left, and the old SQL Server table versions with the buffer pool and stuff like that, the data group, database file groups on the right side of it. The blue part here represents the memory optimized tables and indexes. The green up here is the natively compiled stored procedures and schemas. So if you have a query that comes down into the ordinary T-SQL query window, let's take Management Studio for instance, then that is able to reference both the ordinary disk-based tables and the memory-optimized tables and indexes. If you have a natively compiled stored procedure, you can only reference the memory-optimized tables and indexes. There's no link back to the disk-based. So just think about that. We can only go forward if you're in old-fashioned SQL Server, disk-based SQL Server. You are able to reference everything But if you're in the new fancy version of the memory optimized world, you will need to stick to that. You cannot go back into the old disk-based tables. So let's start up with it. Let's take a look at what it is. So basically, let's just start by creating a database. Create a database, and just as we already done it, or always done, create database, given it a name. It's only this part of it here that's a bit weird. Who has ever created a database using a Latin 100 bin 2 collation? But in SQL Server 2014, that is the only collation that's supported by natively by memory optimized tables and native compositor procedures. So keep that in mind. 2016, that limitation is removed. Now here comes the trick. You'll need afterwards to alter the database, add a file group that contains memory optimized data. So let's do that. We also need to tell it where to put the files, because even though it's called memory optimized data and it's kept in memory, it's still ASIC compliant, which means that everything is, unless you tell SQL Server otherwise, is persisted to disk. So even though that we are operating only in memory and everything is super duper fast due to that, then there is still a file group and still a file where everything is written into. So just going back one bit to the slide here, you can see we still have the transaction log, and that still everything is written to the transaction log and then going to either the memory optimized tables file group or the data file group. So we're still not risking the data here. So let's go ahead and let's just tell it where to put that file group. Put that on the fastest storage that you can find. I have it here on SSD. Creating the table is also a bit, well, different than we used to. As you can see, we can create inline indexes here. So in this case, doing this gives us a non-clustered index with the name of IX last name on the last name column. And also, we do have a whole new type of index that's used and only available on memory optimized tables, which is the hash index. So when we create a table, we need to give it at least one index, because it's the index that binds the whole data set together within memory. In this case here, I'm giving it a hash index on the employee column, and then giving it this hint here, calling it with bucket count. It's because a hash index, and those of you who might have some .NET or whatever experience from more traditional development, will probably know about these kind of indexes. But in this case, the bucket count tells how many unique values can we expect to get within the index. In this case, I just specified 1024. If that number is too small, you will not get the full effect of your memory optimized tables, because it will then have to put more than one unique value into each bucket, and that means that searching through the index will be a bit slower. On the other hand, creating it with a too big value means that there will be too many buckets to search. So getting this value here right is one of the main tricks within memory optimized tables to get the maximum performance. In SQL Server 2014, there's no support for online alteration of indexes or tables. That means if you need to change this value, you will actually have to create a new table with the new value, move your data to that table, drop the old table, and rename the new table. Really tedious, and luckily it's one of the things that has been changed in 2016, so you can now do an alter index, changing the bucket count. Otherwise, it's just saying memory optimized on, and then we have this new thing called durability. durability is what tells SQL Server if you want it to persist the data on disk or not. In this case here, its durability is schema and data, which means that it persists both the schema and the data to disk. We could also just say schema only, which is what you will use if you have a table that contains data that you doesn't really care about. It could be session data from your web server, or it could be a staging area for your data warehouse data, something like that. Data that doesn't really matter if it's lost. You can then say that the durability should be schema only, which means that data will only be in memory. If your SQL Server crashes, you lose the data. If SQL Server turns off nicely and by the book, then it saves the data to disk and it's there next time you turn it on. But if the disaster happens, you lose your data on schema only. Schema and data, the data is persisted to disk through the transaction log, just as we know it with a disk-based table. So let's create the table here. Yeah, and then we just get an error saying that we needed to use the bin2 collation. So yeah, well, which was kind of what I started out telling you, but we can just remove that there, and then we should be fine. Not being master, but we need to use the actual database, which was also why we got 0, because the database uses the bin2 collation, so that will be fine. So now we've actually created a table. It takes a bit longer to create memory optimized objects than we're used to. It's because it actually creates a DLL and links that DLL back to the SQL Server.exe. That we're going to draw along with that. Just keep in mind that things takes a few milliseconds more than we're used to. That was the memory optimized tables. Created the database, created the table, created the index. And the second part of the memory optimized world is in native compile store procedures. Those are machine compile code. So whenever you create something here, it's once again, it's compiled into C and represented in the file system as a DLL. You can actually go find it and then link back to SQL Server.exe. So creating a store procedure here, once again, we have some new things. Create the procedure. Well, yeah, we know that. With native compilation, okay, that kind of makes sense. We want it to be native compiled. It has to be schema bound. You need to tell it who to execute as. And you need to tell it that begin atomic with, which means that if it's called from an existing transaction, it just joins that transaction. If it's not called within a transaction, it starts on a transaction. You need also to specify that that transaction isolation level should be snapshot. You need to give it a language. The reason why you need to tell it all these things here when you compile it is that it's optimized for speed at runtime. So for SQL Server not to start evaluating all kinds of system parameters and derive which execution context, which language context, all of those things it should need, as a normal store procedure actually does when it's called, we need to tell the native compile store procedure that whenever you compile it, and that goes into the compilation. So when you run it, it does not consider any of these things, it just runs. So let's just make sure it's not there to begin with, and then build it. And again, as you can see, it takes a few more seconds than we're used to actually create these here. It's not like it's a huge bunch of code on that. It should do all kinds of funny things, right? So it should just have been like a millisecond to create this one here, but it actually took it 8 seconds to create just a store procedure. But it's there now, and running it will be super fast, but we'll go back to that a bit later. So continuing with the slides. One of the reasons why the memory optimized tables are very are fast and are really useful is that it uses an optimistic concurrency control called row versioning. So instead of locking the rows or the tables that it's updating, inserting, or deleting data from, it's just using a row version. That row version has a begin timestamp and an end timestamp. So whenever a transaction starts, it starts with a timestamp, of course, and then whenever you access a table, it uses that timestamp of the transaction to derive which rows it can see and what content of those rows it should return. So if we have a query coming in that has a timestamp between the begin timestamp and the end timestamp, then that row is returned. If its timestamp is outside of the begin and the end timestamp, then that means that that row is ignored. So whenever you update a row or you delete a row or you insert a row, it doesn't really do that. It just alters the begin and the end timestamps, and then it creates a new row. Of course, on an insert, it will insert a new row. But an update will give an end timestamp to the existing row and then create a new row with a begin timestamp and the infinited as the end timestamp. Deleting a row just says the end timestamp. So in that sense, every transaction relies on its timestamp to figure out which rows to return and what values it should return from it. There is a garbage collector that removes the actual rows afterwards. So whenever the end timestamp is less than the begin of the earliest current transaction, the row is terminated and deleted completely. A few considerations for memory tables, as I've kind of hinted already. In 2014, it's not a super duper production ready feature, if I may be frank. There's no foreign key and there's no check constraint. We don't have any identity columns. You can use a new ID to get kind of identity, but it's not that operational. We can't alter any objects, and we cannot add or remove the indexes. We always need to go and recreate the tables and move the actual data into it. Also, bear in mind that all data has to fit into memory. And due to the row versioning I just mentioned, Microsoft recommends that you have at least twice the amount of data or memory as you have data. So if you are planning on putting in 50 gigs, you'll need 100 gigs of memory on the box to be able to do that. And it only supports 256 gig in 2014, so that also kind of puts a limitation on the amount of data that you can put in those tables. The native compositor procedures are even kind of worse because Microsoft had to rewrite the entire T-SQL stack. As mentioned, native compositor procedures are really aggressively compiled into C and then further into actual machine code. So whenever they execute it executes as machine code and not SQL Server statements. So in that case, a lot of work went into rewriting and building that whole thing once more in what's machine code basically. So as a rule of thumb, if it worked in SQL Server 2000, it will probably also work in native compositor procedures. If it's added after SQL Server 2000 and you are using SQL Server 2014, do not expect it to work. No auto joins, no union alls, no in, no exists, no constraints, merge. You can't do an update or delete with a from clause. Whole lot of things that you just need to work around to get this to work. But as mentioned already, a lot of those constraints have been removed in 2016. So starting from 2 weeks on, we can actually start to use this here for something production-based. But in 2014, yeah, it was good to get to know the product and get to work with what we can expect from it from a performance perspective, and to know what, if you know the limitations of the product and you know how to work around them, then yes, it is usable, but it's gonna be a lot easier from 2016. Yeah, as I already mentioned, it works seamlessly with current SQL Server objects if you are not within the native compositor procedures. If you're just on the query window, you can create both memory optimized and disk-based tables. It is fully ASIC compliant unless you tell it to not be. So you're not risking data even though it's memory based. Mix in-memory and disk-based tables in the same database, and your transaction can span in-memory and disk-based tables in the same database. That is important to stress, and as long as you are not using native compositor procedures. So why on earth did we even consider starting to working with this? Well, it was back when SQL Server 2014 was just fresh out of development. So this work here was done in the mid-2014, and we wanted more speed. So it was worth trying out to see if we can actually get those 10 to 50 times faster performance compared to what we were having at the moment. And what was it suitable for? Well, in V1, which means SQL Server 2014, it was recommended for applications where all, or at least most, of the business logic was in the database as stored procedures, concentrated on a subset of tables or stored procedures, and not chatty, not a lot of small communication, but something where you would basically rely on your database to do the hard work. Of course, you needed to fit your queries within the very, very basic T-SQL surface, and you needed to be able to have your data in memory, or at least your hot data in memory. I'll come back to how you can do that, because even in 2016, that's still a constraint that you are limited by the amount of memory you have on the box. So even though the amount of memory that, or the amount of data that you can fit in a memory optimized table has been increased significantly in 2016, still need to have that amount of memory on the box to be able to use it. I'll show you how you can cheat a bit about that one. So I've talked a lot about performance, and let's try and see what we can actually expect. The RML stress tool is a command prompt utility where you, this time. Here you have the OS stress, which is what just sends a lot of SQL queries, specifying into which server, localhost, instance SQL 2014, to a database called VentureWorks 2012, and then it's executing this statement. And it's doing such 100 times. So actually just doing a stress test of your SQL server. So running this here, we are moving 10,000 times 100 rows. So we're running 100 concurrent connections into the database. Each of those are moving 10,000 rows. I did the same thing on a disk-based table, and that took me 35 minutes using disk-based tables and the stored procedures. So the exact same setup, just on a disk-based. What we're doing now is native compositor procedures and memory optimized tables. We're gonna spare you for watching the 35 minutes disk-based. This one here will take somewhere about, give and take, 2 minutes to complete. While we wait for that, if there's any questions, then let's have them now.
I don't see any questions yet. Anyone wants to ask questions?
Okay.
No, but it brought attention to the people. I can see who is doing something else, you're just going to other applications, checking the emails, and when I'm asking other questions, everybody suddenly coming back to the presentation. So it's good.
Okay, let's continue.
70% now are listening.
Good, so no question, let's just continue while this one here finishes. So while we wait for those 2 minutes to pass, let me tell you a bit about what it was that we were actually converting. We're converting an application called Effector. As I mentioned, it was from a previous workplace. It's a portal built for maintaining, well, for building and maintaining data warehouses. It's a web-based application where you can set up your data warehouse and you can build your relations, build your data marts, build your OLAP cubes, and your process modeling containing also master data and security. So what we were trying to get here was the ability to move the data within this data warehouse. Actually, and the data warehouse, the application contains its own ETL framework, and it was that framework that we wanted to rebuild as memory optimized tables in order to be able to move data much faster than we had previously been able to. So we started out doing a gap analysis, which is also what I will recommend at all time whenever you start doing anything that's memory optimized. Try and see if you in some way does your application match the limitations or the features, depending on how you look at it, from memory optimized tables. Our application Effector contained dynamic SQL. It relied really heavily on dynamic SQL. All SQL statements were built from metadata at runtime. So whenever something was executed, it just went in, built a dynamic SQL statement, and fired that one off. Not supported within memory tables. So that was kind of the first hurdle. We needed to figure out how to go around this. What we did, which was probably the obvious way of doing it, was just to persist the actual store procedures within SQL Server. So instead of relying on them being dynamic at runtime, we actually built the store procedures whenever somebody did a configuration change within the portal. The portal itself also used foreign keys. We removed that and enforced it at the application layer instead. Primary keys are somewhat supported by memory optimized tables as new ID, as unique as grids. So we could turn that into our primary keys instead. Inner joins, no problem at all, that's fully supported. We had a lot of outer joins, not supported at all. Truncate, well, you can use deletes. Deletes is pretty fast within memory optimized tables. Or if you have a lot of data, just trash the table, recreate it, might be faster. We were moving really, really large amounts of data, and that is something that this technology is really good at, but it was relying heavily on merge. So our main issues with moving the application to memory optimized tables were with the outer joins and the merge statements. So let's try and go out and see what you can do to overcome that. Mainly because the merge is actually still not supported within 2016. It looks like my virtual machine has, let's see. Sorry about that. It seems like it's running out of disk space. Just let me just delete a few things. Sorry about that. That was not part of the demo. Let's hope we can get this one here up and running again. Otherwise, this is going to be a kind of dull session. Great. I had to close that one down. Sorry about that. Looking into the SQL that were used by the application itself, it used somewhat like this, just wrapped into a dynamic SQL statement. So classic merge statement using this one here, doing left joins, and then whenever matched, updating. If no match, then it basically just inserted the row. That was the statement, or is the statement that's used for all data movement within the application. So we tried out a lot of different things to do it. I mean, started out with just being completely blue-eyed, not having read any kind of documentation. So create a merge statement within the native compiled tables and getting not supported. So, okay, needed to do something else. Try to figure out what could we else, how could we else do this? So the order join, insert into the table, and the order join here, you see, not supported. Insert into, and then just specify -1 as all the values, and afterwards doing an update and setting the statement to from this one here. Well, the observant attendant will have noticed that I said that that is also not supported. So let's try and see. Well, in this case here it is, because it's not a native compositor procedure. So here we can do it, even though it's memory optimized tables. It just defaults back to being not memory based, but doing it as an ordinary T-SQL stack. But if you try to compile this here into a native compositor procedure, it will fail. So what can we do? Well, not that many things left in the toolbox, actually. Let's revert down to our old-fashioned while loop. So not that common to actually use a while loop to move like 1 million or 10 million or 100 million records, right? This here is row by row, which is what we've always been told not to do. It has always been what you would go to really far lengths to not do. And I mean, doing this here on the normal SQL surface would be agonizing slow. Start out by declaring a lot of variables. We have one variable for each column within the table, and then we loop through them, setting the actual values to whatever was in the table. This is from our staging tables. Remember, this is an ETL-based application. We're moving data from the staging area, combining it to the dimension, and putting it into our fact table. It doesn't really matter what the application does. It's more like the way of doing this here. You can use that in all kinds of applications. But in this case here, this here is done to do an order join. So we put all the records into variables, and then we have the values that we want to look up. So we take in here the employee ID. It's a column we're going to add. And then we select the employee ID, where the business key is the employee key. So in this case here, we're actually doing a left join to the edv.employee on the business key, equal to whatever was in the table as the employee key, and the current is 1. Doing that for all the columns here. So this is the way you can do a left join when you're not allowed to do left joins. Doing the merge part of it, well, we declared to a couple more variables, saying line exists as a bit, 0, and then the ID as an integer. Then we're going into the table that we are merging the data into, looking for something where the sales order number is the sales order number, sales order line number is the sales order line number, which is the same thing as we do here in the merge statement on. So if the line does not exist, that means that this one here did not return anything, then it will have the default value of 0. So we just insert the value. But if the line did exist, that means that this here returned a row, and it then said the ID of the in the table that we're merging the data into. Then we'll just update that record, knowing what ID to insert it into, and then we'll loop that one, and we will fire off the next one. So this here is done on a row by row basis on the number of rows that you have. Doing this here for, well, I have a small integration service package here, which symbolizes the logic that I used. There are all the dimensions that we start out with using. 1, 2, 3, 4, 5. And then let's zoom a bit. And then moving the fact, where we can see that we are moving, well, we're moving 1,000,000 rows, just doing a select top 1,000,000. So on the disk-based application, doing the equivalent of this here took somewhere around 40 minutes. So let's try and fire this one here off, and as I do not have 40 minutes left of this presentation, let's hope it's a bit faster than that. So as you can see, start out by deleting. We don't have any truncate, so we are deleting, and then we're loading, and we're actually loading it twice. This here just puts the data in from the source system and into the staging table. And then it fires off a store procedure equivalent to this query I just showed you. So usually it's this step up here that's the slowest part of it. that is where it's actually moving data from one database to another database. As you can see, presently that's what we're waiting for. We're waiting for it to move that 1 million lines from the source system and into the staging area of our ETL flow here. The dimensions are already done. Those are already pushed into both the data mart or into the EDW and into the data mart. So we removed those tries actually, but they're not that big. So we are, as I said, we're waiting for it to move the actual data. This here is not memory optimized yet, except for the table it loads into is memory optimized, and it is schema only. We don't care if we lose the data if our SQL Server breaks down. Now it's running that same store procedure that I showed you right before. Remember, this one here is moving 1 million rows, doing all kinds of left joins and merge equivalents, so to speak, and it's doing it on a row by row by row basis. So it loops 1 million times, setting those variables to the value of the person row, doing all the lookups into the other tables, and then determining if the row exists or not, and putting it in too. And as you can see, we did so in 1 minute and 56 seconds. So a really, really, really impressive performance gain compared to those. I wanted to show you this one here. 1 minute, 56 seconds compared to the more or less 40 minutes it took on the disk-based same version. So working with memory optimized tables is very much about using your imagination. You need to find other ways of doing stuff. Can't just rely on what you know to be the best way of doing it. It's a new technology, and that means it requires you to think out of the box, to do things whole ways than you would always have, or you would have done it usually. You're not tied into your ordinary toolbox. What did not work within disk-based SQL Server might be the best solution when you're working with memory optimized tables. Remember, it is machine code that we're actually firing off. It's not T-SQL statements. So the execution plans and all those kinds of stuff are completely different. Speaking about execution plan, on a native compile store procedure, the execution plan is compiled into the store procedure. Again, SQL Server is built for, or it's not going to use the time to do a execution plan when you run the store procedure. It's built for speed, so the execution plan is compiled at, or is built into the store procedure at compilation time. So if your amounts of data changes dramatically, you might actually want to, from time to time, to just recompile your store procedures for the execution plan to be refreshed and updated. So yeah, native compile store procedures are definitely not T-SQL and should not be thought of as T-SQL. But as I have said a few times, things are changing. SQL Server 2016 is coming in 2 weeks. And I'm not going to go through all these features and limitations, but I would like to highlight that the alter procedure is supported. Alter table is supported. So you can actually do stuff where you don't need to drop all your tables or recreate them. You can alter the table and rebuild your index, stuff like that. You're not you can use all collations in the bin too. you can use a check or you can use a unique constraint. So that means that you can actually tell SQL Server that this is your hot, this is your cold area. Let me try and show you how we can do that. Let me just try and see if I can get that
I have a question.
Zoom bar to go away. Yeah, sure.
In fact, what did we see? That the procedural stuff is more suitable for those procedures than a set-based query. Do you think in 2016 it will the join query will perform faster than the procedural way, you know, so row by row, or maybe
Yes.
it is the way that we should work with the natively compiled procedures?
Well, in 2016, auto joins fully supported. Union all those kinds of things are fully supported as well. If they will perform fast or not, I guess depends on your workload. The merge statement is not supported in 2016 though. So if you're going to do something like a merge, you will still need to do what I just showed you or the equivalent of this. I would definitely advise to still go around, try this here out, and then try out the auto join to see what is the fastest. Anyway, I mean, writing an auto join is probably what most people would do, as it's what is closest to the way that we do T-SQL development ordinary, and it will also be where you requires you the least work to actually create or recreate your stored procedures as natively compiled from what you might already have in an existing application. So on that sense, you will be able to use the auto join, and you should do so in most cases. This year is a bit tedious to develop in that way, but if you rely on a merge statement, this is the only way still within 16 to be able to do it.
No, I wonder, it could be a very interesting benchmark just to compare some. I'm not talking specifically about the merge, but you know, taking some set-based stuff and just compare it to a row by row implement solution, and just because it's, you know, it's being compiled into the code, and maybe it is the way you should work with the native compiled procedures. Maybe it will be faster.
It might be that it is faster because it is really fast to do it in this way.
Yeah.
It takes next to nothing to move data and do stuff like this. And it gives you really, I mean, you have the full flexibility and you're totally in control about what happens because you are at the row level. So if you want to do anything at a specific row with a specific type of data, you just put it in here and it's done like that.
Yeah, we have a question. From Eric. He asks if the in-memory tables apply to standard and express editions, or they're only part of the enterprise edition.
For now, that means 14 and 16. It's only enterprise and developer edition. 2016 developer edition is completely free, and you can just download it actually and use it. It's one of the new things in 2016, and there it is. But I mean, you're still under the constraints of what you are allowed to do with the developer edition, though.
All right.
But it is an enterprise feature.
Thank you.
Last thing I want to show you is how to overcome the thing about having a hot and a cold data zone, where you have your hot data in memory optimized tables and you have your cold historical data on your disk, on your old spindles. In 2014, this is not completely gonna work. Well, it is gonna work, but we can't completely separate the two because we don't have a constraint. that was going to be with us in 2 weeks in SQL Server 2016, and there we can go build it completely. What I'm doing here is that I'm creating a table, just an ordinary disk-based table, setting a constraint on it with a default of the get date. So in this table here we have we're creating a table with a constraint on it that tells SQL Server which data can go into this table. And here we're creating the equivalent of that table with an in-memory. The constraint here is just for the default of the value. It's not a constraint in that case. But otherwise, same thing. You can see here we have the constraint where we tell it that the sales order ID in this table here will be between 50,000 and 100,000. We cannot do that on the memory optimized table in 14. We can do it in 16 though. And then we create a view on top of these two tables where we have the in-memory, and then we just do a union all, and we do the same thing with the sales order detail. And those of you who remember really good back, the terminology of a partition view might mean something. But it is actually where you have a view on top of two or more tables. Those tables have constraints in them that tell SQL Server what data can go in here. So when you insert the data in through this view, SQL Server knows which table to put them into based on the underlying constraints of the tables. So in this case also, when you query this view here, since I do not have a constraint on my memory-based table, it will always query my memory-optimized table. But that is a small, fast subset of my data, so it's not really taking any performance impact on that one here. But my large disk-based historical table has a constraint on it. So that means that whenever I query this table, SQL Server will know what data can be in the disk-based tables. So in here can only be data with a sales order ID between 50 and 100,000. So if I ask for sales order ID 10,000, SQL Server will know that it's not down here. It can't be down here. So it will not even start to query the disk-based table. It will just query the in-memory table. If I ask for sales order ID 70,000, since I don't have a constraint on the memory optimized table, it will need to scan that one and also the disk-based table. As I said, the memory optimized here is just our hot data zone. It is usually a small one and it's really fast. So doing it like this here and then have a job at nighttime or something that moves the data and remove and also these constraints on the disk-based table on what is your definition of cold data enables you to have a hot and a cold data zone within the SQL Server and having just your hot data within memory and all your cold old historical data put down on disk. In 16, you can put a constraint on the memory optimized table and you can complete these here. If there's a constraint on both of them, you can use the view to insert data and then SQL Server will know which table to insert it into. In 14, we needed to build that logic in a stored procedure on the side though. But this here is the best way and the only way that I know of, unless you're going to build it into some kind of application layer where you can actually separate your data in a hot and a cold data zone. So returning to our gap analysis from before and going 2016, as you can see, the only thing not supported is the dynamic SQL, truncate, and the merge. So for us to be able to do what we do, we'll still need my row by row while loop. But for many other kinds of applications, you might be able to actually just put your code directly into memory optimized tables and store procedures. So yeah, as I showed, we had a really big performance gain going memory optimized and natively compiled store procedures. You need the native compiled store procedures to really benefit from the product. Just putting your data into memory optimized tables usually won't do it for you. Then that is only if you are really log bound and you need the optimistic concurrency control, but then there are other ways of doing that as well. So yeah, you have the guides that comes with the product, where you can go in and see if it works, and use the memory optimization advisor and the tables, and it will show you on a given table or given store procedure what is not supported and what is supported, and use that to get an idea about what changes you'll need to do to your code before actually going into your boss and telling this is a new thing. So get an idea about the work behind, and the advisor will give you that one. That kind of wrap up my session right on time as well. So if there's any question left, let's have them now.
I don't see any for now.
Good.
Anyone?
And that's
last chance.
Otherwise, you always feel free to contact me afterwards. My contact information, as mentioned, was on one of the first slides. Always happy to help out, to to see if I can. If there's anything I can be of help with, then just contact me, or go to my blog, fill out the contact form if you can't remember any of the other contact information. Always happy to help.
All right. Thank you very much. I really liked the partition pruning stuff. You know, I really like partitioning and native partitioning and all style partitioning, and we are combining, and now we can combine 3 features in one. Natively partitioning tables, on the top of that, old style partitioning, and the first table will be in memory. Gonna be really cool. Thank you very much. Thanks everyone.
You're welcome.
Have a good day. Bye bye.